Okay guys, chapter 9 starts with some information about probability distributions and expected value. So probability distribution takes events and breakdowns the possibilities into probabilities. We've spoken a little bit about this in chapter 8. The data is then put into a table or histogram, which is kind of a bar graph. And suppose a fun-sized bag of M&Ms contains 9 brown candies, 6 yellow candies, 7 red, 4 orange, 2 green, and 2 blues. Make a probability distribution and draw a histogram. So really, a probability distribution is the chances of, if you pick one M&M, what are the chances for each color? So we can kind of make a chart. Color, frequency, and then what we call relative frequency. A probability distribution uses a relative frequency distribution. So let's see, we've got brown, yellow, red, orange, green, and blue. That tells you that you have 9, 6, 7, 4, 2, and 2. Now the relative frequency is you take those numbers and divide them by the total. So the total is 30. So we have 9 over 30, 6 over 30, 7 over 30, 4 over 30, 2 over 30, and 2 over 30. Now you could get this in, histograms could be using either one of these. Now more likely in stats you'll use this in terms of relative frequency, but it really depends what they ask you to make the table about, frequency or relative frequency. So we've got color and we've got frequency. Brown, yellow, red, orange, green, and blue. We'll just do the regular frequency histogram for now. So the one thing about histograms is that all the bars touch the left side and they're all even spaces and they touch each other. So no space between the bars. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So brown is the size of 9. Yellow, there are 6, red 7, orange 4, green 2, and blue 2. So this is what a histogram looks like, and that's really it. And we won't really focus on that too much. The 9 one's really about expected value. So the relative frequency talks about the chances of something occurring for every one. If you pick one M&M, what are the chances of it that it occurs? So an expected value formula takes that idea of relative frequency and expands on it to say, well, if across everything that's expected, if there's a numerical value, we can see over the long haul, what's the average amount you're going to get from doing this one time. A good way to illustrate this is it's the sum of all outcomes times their probability of occurring. So a $20 bill, 2 $10 bills, 3 $5 bills, and 4 $1 bills are placed in a bag. If one bill is chosen at random, what is the expected value for the amount chosen? So we have the bill and the frequency. We'll do the frequency in relative terms. This is the probability that occurs. So the $20 bill, a $10 bill, a $5 bill, and a $1 bill are options. And that's their numerical value as well. Out of the 10 bills, only one is a $20 bill, so this would be 20 times 1/10. There are 2 $10 bills, 3 $5 bills, and 4 $1 bills. So to get expected value, we take these two columns and multiply them together. So this is our x times probability of x. And these are our x and probability of x columns. 20 times 1/10 is $2. 10 times 2/10 is $2. 5 times 3/10 is $1.50. 1 times 4/10 is 40 cents. Now the sigma we've seen before is the sum. So I have to take this column and add them all together. If I do that, I get $5.90. What does that mean? On average, over the long haul, picking one bill from this bag is worth $5.90. So now, of course, if you actually picked a single bill, will you ever get $5.90? No. But it illustrates the idea of what can happen. So I'm going to skip forward to a dice question and a more realistic problem you might see. So I'm going to skip problems 2 and 3 in the notes and go to 4. A dice game involves rolling 2 dice. If you roll a total that is 2, 3, 4, 10, 11, or 12, you win $9. If you roll a 5, 6, 7, 8, or 9, you lose $6. Find the expected value you might win or lose when you play the game. Okay, so our 2 possible outcomes is we win or we lose. If we win $6. If we lose, we get minus $9. So what are our chances? Let's look at the 2, 3, 4, 10, 11, and 12. That's this top corner and the bottom corner. There are 12 of those total out of 36 dice rolls, which means the other ones are the other 24 out of 36. So again, I multiply those 2 together. This is just 1/3. 6 times 1/3 is $2. -9 times 2/3. Oh, did I get that backwards? Yeah, you win $9 and you lose $6. Can't read my own problem. Okay, so 9 times 1/3 is actually $3. -6 times 2/3 is -$4. When I add them together, that's -$1. What does that mean? It means on average, over the long haul, you lose $1 each time you play the game. A rather unpleasant reality. I really love this problem the most. Life insurance policies will pay a beneficiary a certain sum of money if the holder dies. Suppose a company sells $250,000 policies for 1-year life insurance to 49-year-old women for $530. Compute the expected value of the policy to the company if the average 49-year-old woman has a 0.99791 probability of surviving the year. Okay, so only 2 things can happen. She lives or she dies. If she lives, what is it worth to the company? She paid them $530 and they paid her $0. However, if she dies, she paid them $530 and they paid her $250,000. So what do you have to do? 530 minus 250,000 to get negative 249,470. What are the probabilities of each of these occurring? We've got 0.99791, and then 1 minus that. 1 minus 0.99791 is 0.00209. And again, you multiply these 2 together. What's 530 times 0.99791? It's 528.89. What is negative 249,470 times 0.00209? It's negative 521.39. Of course, we add these together to get a total of $7.50. Means on average, again, over the long haul, each policy is worth $7.50 to the company. And frankly, they should charge more because a policy being worth $7.50 is not that much. The last thing that this section has you do is really easy. It says find the missing value for the probability model. Remember that all values add to 1. So you just add them all together and see what's missing. So if I add 0.28, 0.34, and 0.12 together, they add to 0.74. So the missing value is 1 minus 0.74, which is 0.26. Even if there's more than that, it works the same. 0.22, 0.13, 0.57, they add together to be 0.92. So the missing value is 0.08. And that is all for 9.1.